In this question, we want to figure out what three-dimensional figure is created when we take these blue two-dimensional planes and rotate them around their given axes. So in this first one here, we're going to take this blue rectangle and we're going to rotate it around the x-axis, and we want to figure out, well, what was created. Now, disclaimer here, this is so hard to describe in this situation, like on the computer. So I'm going to do my best. It's not going to be perfect, but I'm going to try. Well, imagine if we were looking at this x-axis. So from right to left, we're staring, like if you're staring down a barrel or something, you're looking directly at this x-axis. Well, you'd have the x-axis looking like a dot, and then from the axis going upwards to like there, that's going to be the edge of this two-dimensional plane, right? Now, we're rotating this rectangle around the x-axis. So this edge gets rotated around just like that. And then when it gets back to the starting point, you have your three-dimensional figure. Now I'm going to take away that little line that we were rotating around with just to make this object look a little more clear. And now it looks like like looking at it on its side, that's going to be a circle. And then technically, like over on this view, since we were rotating it around, there's going to be more of it down here. So we have this big rectangle on a side view, and on the other side view, it's a circle. So this is going to be a cylinder. Okay. So again, it's tough to explain it, but I'm doing my best here. Now we have another one, and it's going to be a half circle that's rotated around the y-axis. So just like we are looking down the axes and this left side, we want to look down the axis over here. So if you're looking downwards, imagine if this was like a flagpole and you're looking down a flagpole, it would just be a dot, right? And then kind of branching off from it is going to be the edge of that semicircle here. Now we want to rotate this semicircle around the y-axis. So I did that up here. And then when I do it down here, it's going to go around the y-axis back to the beginning point. So this top edge is going to rotate all the way around and stop right there. Now I'm going to get rid of the arrow that was just showing me revolving it around. There we go. So looking top down, it looks like we've got a circular figure here. Color that in. And then remember, I'm revolving it around, so I want to show that I'm going to have some blue area here as well because it's rotating around. So that's going to be blue as well. So looking top down, it looks like I have a circle, and then looking on its side I have another circle, so that's just going to represent a sphere. Okay, again, I did my best to explain it, so hopefully that makes sense, but I think that's about as good as I could get for now. In this question, we're kind of going backwards. So we have our three-dimensional figure, and we want to figure out, well, what two-dimensional plane did that come from? And it's being revolved around our y-axis, so I'm going to cut it down like this. So imagine my cone here is cut in half. Now I'm going to put that on a brand new XY coordinate system here. And then my cut is going to be down the center like that. And then we have to figure out, well, what was left over? Well, let's say we're going to take everything on the right side of the vertical cut. So we're going to have this part and then this part and then all of this. So we'll go down and then to the right and then all. So it looks like this is going to be a triangle right here. So the triangle was revolved around the y-axis, and that gave us a cone. Now in this question we have a cylinder, and we're making a bunch of cuts on it, and we want to figure out what two-dimensional plane is exposed, so we're looking at cross sections. And it's a little different than the previous questions. So let's start with A, and we're going to look at horizontal line A. A. So that's going to be this one right here. Well, imagine that you have this cylinder and we cut it through the middle. What we're going to be left over on the side, and this is extremely hard to demonstrate. What's left over here on the side, this face is going to be a semicircle, right? And we want to figure out what's going to be the face that is exposed on the top part here. So this face right here, that's going to be the cross section that we're looking at. And if you kind of look at it like top down, what's going to form is a long rectangle. And this side of the rectangle would be like the top part of our semicircle that was shown right here. And it's really tough to see sometimes, but again, this is the best I could explain it. So let's try B. B is going to be the horizontal dotted line. And just like A, when we cut this cylinder across, there's going to be another semicircle that kind of happens on this face right here. So that's going to be one side, and then that's going to be the surface area that appears again. And just like the first one, horizontal line A, it's going to be a rectangle. But the thing about this rectangle is that it's not going to be as big as the rectangle that was formed with the line A, because let's imagine this was the first semicircle here. Well, then the one that we're looking at right here, imagine this is going to be blue. That's going to be cut a little bit lower down on the cylinder. So then this side right here is going to be a little bit shorter than this side up here. So this cross section for B is going to be a little bit smaller in area compared to the cross section rectangle that was made in part A. So let's try part C. So we have vertical line C, and we're cutting it right through the cylinder. So then the cross section that is exposed is going to be a circle just like the edge, right? Because say we cut this in half, and what's exposed is going to be, try to draw this in here, but just another circle. Okay, so now part D, and this should be vertical line D. What happens when we cut down this way, right? Well, that's going to be the same situation as C. I'll do this in another color. It's going to be a green surface that's going to be in the form of a circle. So it's going to be the same shape as a cross section as part C, and these circles are actually going to be the same diameter as well. They're not going to be changed like part A and part B, the different rectangles. So C and D will create cross sections that are identical. So here we have a pencil company that is cutting a pencil in half long ways. So let's say this is the eraser, and this might be a little like metal part at the end by the eraser, and then we have the long pencil here. And to start, which is really important, it says that the pencil is not sharpened, so it's going to come to like like a corner here. It's not going to be sharp. It's not going to come to a point. Put it that way. And it's asking, what is the shape of the two-dimensional surface that would be exposed after the cut? Well, if we cut this long ways, so taking a knife and cutting it long ways like this, well, the surface area that's going to be exposed is just going to be a long, skinny rectangle. And because the pencil is a cylinder, it's going to look exactly like what I have down here on my screen. Now, there's a second part, and this is where it gets a little tricky. It says, what shape would be added to the cross section if the pencil is sharpened first? So let's say I want to duplicate my shape here. This is going to be not a very good copy, but that's the eraser, and then this is going to be the little metal part, and then There goes the long part of my pencil. There we go, not bad. And then it's saying that we want to be sharpened. So imagine that this part right here is going to be sharpened. So it comes to a point that's going to be my lead. And then I could get rid of this part here. And that's the lead part. So that's going to be a sharpened pencil. And it's saying what shape would be added. Well, we have our long rectangle, and that will be shaded in with green all the way up into here. So it'd be a long rectangle. And the part that would be added would be this triangle right here. And if it was 3D, that would be a small cone, but in this case, because we're cutting it in half looking for that two-dimensional cross section, that would just be a triangle.